Okay, this is on parallel lines and proportional parts. And we've already talked, if you have a fraction, that's considered a ratio. Like 3/5 is a ratio. But if I put 3/5 equals 6/10, then as soon as I put the equal sign in between, I make up a proportion. Okay, the first thing they go in this this section is what they call the triangle proportionality theorem. Okay, and you should already have this on your notes. Okay, this is a handout of notes. If the line is parallel to one side of a triangle, pick any side. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides. Left out the end. You guys, if I left out the end on yours, correct it. Yeah, I did. Then it divides the sides into segments of proportional lengths. Okay, so look at our picture. Okay, if these lines are parallel, and you can tell that by the arrows. Remember, this line is parallel to this line. Okay, then BA. Okay, so look at how this is proportional. BA is to CB as DE is to CD. Okay, they are proportional to each other. Once you've got your proportion, then you can cross multiply. Okay. Okay, the next part, Theorem 7.6. That's the converse of the triangle proportionality theorem. If a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then the line is parallel to the third side. So if you get your triangle and this BA is to CB, that's how they're setting it up, as DE is to CD. Another way to say that is AB is congruent to DE, right? And CB is congruent, and they're in proportion. Then that's telling you this line is parallel to this line. Okay, they are the converse of the original one. Okay, then Theorem 7.7, the triangle mid-segment. Where else did we talk about mid-segments? Not in triangles. Trapezoids. In trapezoids, right? We had a mid-segment, and some authors call it, what else did they call it? The median, yeah. Okay, so Theorem 7.7, triangle mid-segment theorem. A mid-segment of a triangle is parallel to one side of the triangle, and its length is half the length of that side. Okay? A mid-segment of a triangle is parallel. So we could go ahead and put in here, this. Okay? If B and this should say D, sorry. I had to adjust my notes last night, so I messed up. B and D are midpoints. Okay, change that to a D right here. If B and D, make that a D. If B and D are midpoints of AC and EC, then BD is parallel to AE. So you can go ahead and add the red arrows. And BD is half of this bottom line. So BD is half of this. Okay? And that's if these are congruent and these are congruent. Okay? Those I should already have marked on there. Okay, Corollary 7.1. If three or more parallel lines intersect two transversals, these are your transversals, this line and this line. Okay, and here's your three parallel lines. If three or more parallel lines intersect two transversals, they cut off the transversals proportionally. So, if you look at this, AB is to BC. So this is to this, as DE is to EF. Okay? That's one way to write it. AC, this whole thing, AC is to DF, this whole thing, as this part BC is to EF. That's another way to write it. Okay, and then the last way to write it, AC, the whole thing, is to just one part BC, as DF, the whole thing is to just EF. They are in proportions. Okay, so there's three ways to write that, the proportions on that. Okay. Okay, then on the back page, make sure it came off on the back page. Corollary 7.2. If three or more parallel lines cut off congruent segments, okay, on one transversal. So here's your three parallel lines going this way. Here's your transversal. If these are congruent, they're marked congruent. Okay, if those are the congruent ones, then they cut off congruent segments on every transversal. So, and this is a big and statement. If I was you, I'd highlight that or underline it or circle it. Okay, remember an and statement, for an and statement to be true, both parts must be true. So if those three lines are parallel and these two segments are congruent, then EF is congruent to FG. Then you can go ahead and mark this one congruent to this one. EF is congruent to FG. Okay? Okay, that should do it for notes on that part.